In this video, we want to analyze the graph of the given function. In this case, it's a rational function. Similar to what we did in the last video, except this one has an oblique or slant asymptote. So we're going to look at the behavior of this, find the intercepts, x and the y-intercepts if it has any, find any vertical, horizontal, or oblique asymptotes, identify in what intervals the graph is above or below the x-axis. So if you look at this, and you can stop the video if you want to attempt this. Otherwise, I'll just continue with this. So first, let's note that you can write this as x squared plus 1 over x. All right, now put this over 1, and then to get the same denominator, we multiply numerator by x and x. I get x squared over x. So I can write this x squared plus 1 over x. And we said in the last video and other videos also that in order for the graph to have an oblique or slant asymptote, the degree of the numerator has to be 1 more than the degree of the denominator. If it's less than the degree of the denominator, then y equals 0, or the x-axis is always a horizontal asymptote. If the degrees are the same, you look at the coefficient of the lead term on the numerator and the lead term in the denominator. In other words, if this was x plus 1 over x, then this would be 1 over 1. Degree 1, degree 1. The horizontal asymptote would be y equal 1. So in this case, we don't have a horizontal, but we do have a slant asymptote because the degree of the numerator is 1 more than the degree of the denominator, is just 1. The denominator is equal to 0 when x is equal to 0. 0 doesn't make the numerator 0, so I know that no horizontal asymptote. We do have a slant asymptote, and x equals 0 is the vertical asymptote. Now in this form right here, you can see what happens to the graph as x gets real large. And that's what we do when we want to find the asymptote, whether it's a horizontal or a vertical or a slant. What happens as x gets real large? Notice here 1 over x, if x gets real large, a 3, a 10, 100, 1 over 1,000, 1 over 1,000,000, this 1 over x basically goes to 0, and you wind up with x. So that tells me that the graph approaches the line y equal to x. Now keep in mind, graph can intersect a horizontal at times. It's never going to intersect a vertical because the vertical asymptote comes from values that make the denominator 0. So it's undefined there. It may also intersect a slant asymptote. Never intersects a vertical. So if it's in this form, in the video where we found the asymptotes, we simply divided the denominator into the numerator, discarded the remainder, and then whatever we got, the quotient was the vertical asymptote. Well, if we divide the x into x squared plus 1, I get actually this right here. The 1 actually turns out to be your remainder, and 1 over x goes to 0. So the slant or oblique asymptote is y equal to x. The graph approaches y equal to x, the line y equal to x. So what else do we do? When analyzing the graph, I mentioned last time, we always plot the numbers and make the numerator 0 on a number line, because those lead to the x-intercepts. We always plot the numbers and make the denominator 0 because those lead to the vertical asymptotes. So we know already from just looking at this, x equals 0 is a vertical asymptote, and y equal to x is the oblique asymptote. Let's cancel this here. So for this one here, x-intercept, there is none. Graph doesn't cross the x-axis because we had the function in this form right here. The right side was x squared plus 1 over x. This was f of x. If I rewrite it as a single fraction, and the only way you're going to have x-intercepts is if there are real values, okay, not complex, but real numbers that make this 0. Well, x squared plus 1 is going to be non-negative. Never it's going to be 0. No matter we pick a negative number or a positive number, this is always positive, so that's why there's no x-intercept. Now, for the y-intercept, you replace the x by 0 to get the y-intercept. And if you have a number, that value is the intercept. But notice if I replace x by 0, I get a 0 in the denominator. That's undefined. So the graph doesn't cross the y-axis, so there's none here. Y-intercept is none. Domain, it's all the permissible replacements for x. Well, the only one that's not permissible is x equals 0, because that's the number that makes the denominator 0, and that's undefined. So the domain is going to be the set of all x, such that x is not 0. So any number will work in the domain except 0. Vertical asymptote, we said it's where the graph is undefined, or where the denominator is 0, so x equals 0. And then for the oblique, for the slant asymptote, is y equal to x. That's your information. And then in the last video, and this is the analysis actually of the graph. And then you put all this together and you graph it. And then on the number line, the technique that most people will use is on the number line you plot the numbers and make the numerator 0. And we noted we don't have any in this particular case. And numbers and make the denominator 0. Well, we only have one, that's 0. And then you have to decide, okay, to the right of that number is the function positive or negative? To the left, what's the case? Well, let's pick 0. We pick a number larger than 0, say 1. Put a 1 where the x is, or put a 2 where the x is. Everything comes out positive. So this is positive right here. So this tells me that to the right of 0, see, infinity is over here. So it doesn't matter how large the number is, as long as it's to the right of 0, it's always going to be positive. Now to the left of 0, though, notice we pick negative 1. Okay, negative 1 squared on top is positive 1 plus 1, that's 2. Negative 1 on the bottom then gives me a positive divided by a negative. So if you pick any number to the left of 0, that means you'll be putting in a negative number. The numerator will always be positive. The denominator will always be negative. So a positive divided by a negative is a negative. So with this information, I can do the graph. I know the graph is going to approach the slant or oblique asymptote, y equals x. I know it's going to approach the vertical asymptote, x equals 0. And I know I have no x-intercept, no y-intercept, so it doesn't cross the x or the y-axis. So let's clear this then, and let's just plot the information. So here's the line y equals x. Now if I go 1 over, go 1 up. 2 over, I go 2 up. Right through the origin. And I know to the right of the, and notice I have the y-axis is the vertical asymptote, so I put it as dotted line. And of course this line through the origin over here is the oblique or slant asymptote. So to the right of the vertical asymptote, or the y-axis, the graph is above, so it's over here. And to the left, below, so that's down here. So just kind of use common sense on this. If the graph is going to be over here somewhere, then there's only two things we can have. Okay, you can have something that looks like this, where the graph, remember, the graph has to approach the asymptote. So you got something that could go like this, kind of like a parabola. Or if it's in here, you can have maybe something like this. Okay, so let's say, okay, without plotting any points, since I know it has to approach the asymptotes, I can draw something like that. Or I could go something like this, approach the vertical. And then on this side, what could happen? Well, it could go something like this. That's to approach those. Or it might go something like this. And then you decide which one you're going to use. Well, it can't be this one here. It can't be this one here because we don't have an x-intercept. This is not going to work. It can't be this one here because there's no x-intercept again. Now these might work. The graph could be in between these two and these two. And you can plot a few points here. So let me erase this and let's say graph was f of x. I'm just going to call it y is equal to, I'll put it into this form, x squared plus 1 over x. So let's just pick a number. What happens if x is 1? If x is 1, so this will be 1 squared plus 1 is 2 divided by 1. That's 2. So that means then that the graph go 1, and then we have a point somewhere here. And then you can just plot some other points, and you'll see that you have some values, some points over here, some points over here. Just with a couple of points, you can come up with this kind of graph, something like this, looking kind of like a parabola contained in there. And then on the other side, we know where the graph has to be below the x-axis. So let's pick a -1. So we go over -1. So -1 squared is 1, and 1 is 2, and then -1, that's the -2. So this will go 1, and then -2, somewhere down here. And you plot some more points, and you'll find some other points on this side here, and this side over here. So you graph yourself, you draw the graph so it approaches the slant asymptote and the vertical one. Now also remember that the graph may cross a horizontal asymptote if you have any. We don't have any here. We have a vertical. It's never going to cross the vertical. It may cross the oblique or the slant asymptote. Now based on what we did here, it doesn't appear that it's going to touch the slant or oblique asymptote, but it'll approach it. So well, you say to yourself, well, how do we know then? Well, let's take the original function x. It was given as x plus 1 over x. See, well, how do I know that it's not going to cross? Because there's some graphs that cross the horizontal or the oblique, never the vertical, because it's undefined. So you can say, well, how do I know that it doesn't go like this and crosses there and then goes back up and never crosses again? Because that's what happens sometimes with a horizontal asymptote. The graph is going up like this and crosses, say, there, and then it comes back down and never touches again. Now if the horizontal asymptote turns out to be the x-axis, you can determine that by how many x-intercepts you have. But in this case, if you want to determine whether it crosses the slant asymptote, set this equal to y equal to x. Okay, so this will be x. If that has a solution, then it does cross. The graph will cross the slant. But notice this x and this x cancel out, so I get 1 over x is equal to 0. Okay. Is there a value that will make 1 over x equal to 0? No, this equation has no solution. You can't say, well, x equals 0. No, x equals 0 is not a solution because 1 over 0 is not defined. So this has no solution. So if you just use kind of common sense, use the number line, you can get the accurate graph for that particular function. Thanks for watching. We'll see you next time.